going to need. I'm just going to go through some of the drawing things that I think are relatively important, right? Most of the drawing things that I think are relatively important. Then I'm going to tell you about some procedures and experimental accuracy things that are quite standard in the mark scheme. Okay, so look at this one here. This one, I've seen this question come up many times already. In fact, last year they did the Okay, in fact, last year they had the exact same question, which a lot of you guys always find it hard to do this question. And for such a hard question, it's only 1 mark most of the time. So please everyone be careful with this here. Right. How are you actually supposed to do this question is, first and foremost, you are supposed to measure how long this thing is. So let's say for example, this thing here for ease of calculation now, right? Let's say it's 5 cm. Okay, let's say it's 5 cm. So what we do is, right, we take this 5 cm and we divide it by 2. 5 cm, you divide it by 2, you'll get 2.5 lah, right? So what happens is, once you have this 2.5 here, you think about it logically lah. If let's say I just place this thing over, wow, Shen, welcome back. It's been a long time. It's your favorite spot here already. I didn't say it. Good. Okay, anyways, like I was saying, guys, pay attention to this. So what happens is, right, if today I know that this thing is going to be 5 cm, right? When I know that this thing is going to be 5 cm, it's going to be hard for me to place it exactly on the 10 cm mark, because as soon as I place it on top, what happens is I cannot see the reading here already, right? So what I do is I divide it by 2, and then I think about it logically. If I want it to be exactly on the 10 cm mark here, I have to take the 10 minus the 2.5, right? Which will give me 7.5 here, right? And I have to take the 10 and I plus it with 2.5 also, which is going to give me 12.5 here, right? If today, looking here, looking at this point here, I notice that here is 7.5, and I notice here is going to be 12.5, right? Then I know for a fact that the middle, even though I don't see it, is going to be a 10, right? So this is going to be depending on how you explain it and how you draw it. Your writing may be more or it may be less lah. For me, I would say something like, I'll draw something like this, okay? I could draw something like, okay, take this thing here, I measure how long this thing is, I'll take the length, and I take the length divided by 2, right? Then after that, whatever it is, this threshold that I'm supposed to put in, let's say it's supposed to be 10, right? I label this here as 7.5, and I label this here as 12.5, right? Once you draw this, and then of course you draw the ruler lah at the bottom, right? You draw the ruler at the bottom here, but you can draw it nicer or more straighter, like it actually doesn't matter, right? Then from here, once you draw this already, right, the examiners, they'll know that, oh, this guy actually knows what he's doing, right? You need to plus and minus it. Then after that, depending on how you write here, you'll say something along these lines. It doesn't have to be word by word. You'll say something like, oh, take the length, divide it by 2, make sure that whatever the middle is, you minus that divide by 2 length, and you plus the divide by 2 length, however way you want to structure it, right? However way you want to structure it, you have a lot of lines here you can write. Doesn't really matter, right? But I think the drawing is more important, because once you do the drawing, then with the drawing itself, the examiners can tell that you know what's going on here. This one comes out quite a lot already, guys. By now, I think Leo just asked me this question as well yesterday. So by now, hopefully everyone knows how to write this as well. So this is one drawing question, which I always wanted to highlight. Then another drawing question, which is obviously going to be these graphs here, right? Guys, few things that you should be very careful with this graph, because it's worth a lot of marks, relatively more marks here. It's 4 marks worth here, right? So the 4 marks are always standardized one. You should know. I hope that you have been doing enough paper 6 by now. For those who have been doing enough paper 6 and have been looking at the mark scheme, right? Hopefully by now you will have noticed that the mark scheme has a standard 4 marks from these drawing questions, okay? It's always going to be this. You label the axis correctly first, right? The axes are labeled correctly. So you see what they want now, right? Don't panic. I mean, on Tuesday, guys. If they say that, usually they'll specify what you should write on the y-axis and what you should write on the x-axis one. If they write this as the y-axis here, whatever you write here, make sure you say that it's A/measured in cm. You must write your units. If you do not write your units, you are wrong already. And in fact, right, sometimes this table here, they won't even give you this. They'll purposely leave it empty, and you are supposed to fill it in yourself, guys. Right? Very important. Make sure you look at the table, the header first, right? And make sure you write the units here. And same thing goes for this also, be in cm, right? Must, is a must. Then what do they want from your second mark? Usually it will be a thin line or it's a suitable scale, right? Is this suitable scale here? Meaning to say, if let's say, right, you draw your scale at the end of the day, right? It ends somewhere like this. It ends somewhere like this. And then you say that your line is like this here. Straight away wrong, guys. Straight away, you'll lose your mark immediately. Because by right, you should fill up at least 70% of the space given to you. If you do not fill up more than 70% of the space given to you, you are automatically wrong already, right? Then if you do not fill it up, then you have to change your scale. A lot of times you have to start from 0, but it is not a must also, guys. If you find that, later, hey, drawing like this, my graph is only like 20 or 30% of the given space. That means to say you don't necessarily have to start from 0. Maybe you could go something like 50, 55, 60, 65, and 70, and so on. Something like that, right? But ultimately, your whole idea is to make sure that you fill up the scale nicely. You should fill up the whole graph. At least 70%. This is a must. Okay. Then this one, draw 5 plots correct to the small squares. I mean, if you lose marks from this, you deserve to lose your marks, right? If you can't even follow the damn instruction, like literally just follow properly, then you can get your 3rd mark already. And finally, the last mark, which is the most important, where students always lose their marks, is a thin continuous line, guys. I've definitely mentioned this in class before. I'll say this again. If you dare draw tomorrow, you draw something like this, then not enough, then draw more, something like this, right? You see, as soon as you draw something like this, as soon as they notice that it's not one line, you lose your marks already immediately. Okay. And then please use a mechanical pencil when you're drawing the line. Okay. A lot of students, they always ask me, does it matter if it's curved or must it be a straight line? The most important thing is they don't actually care. It must be a best fit line, guys. And I've also mentioned this in class before. So let's say your scales are something like this, right? Right. You definitely can't go through all the lines, but what you can do is you can make sure it's a thin, continuous, best fit line. Imagine this is a straight line, by the way. I mean, because I have to draw it with my mouse, so it's not right. But the general rule is it must always be a +1 difference on either side of the graph. For example, here, if assuming that this hits the line, right? What points don't hit the line? This and this don't hit the line, right? And this don't hit the line, right? There's 2 on top of the graph, 2 points on top of the graph, and 2 at the bottom of the graph here. This is a 0 difference graph, but means to say it's acceptable. Even if I have 1 more point here, means to say there's 3 here and 2 here right now, it's still acceptable because it's a +1 difference in the points only. But if let's say you have the 4th point here right now, if this is 4 and this is 2, this is a +2 difference graph. Cannot, no. If you have 4 points on top here, then you must make sure at least you have 3 points at the bottom here. This is a must. Same goes like that. If let's say you have 4 on top, you can go to 4. You could go to 5 also, but you cannot be the 6. Cannot have 6 points at the bottom of the graph. You guys get what I mean, right? Just remember it should be a +1 difference on top and on the bottom of the graph for the best fit line. Then everyone should be okay already. All right. I'm sure you do this at mathematics also. So If you lose your marks, you really deserve it lah. Oh, then after that, if they ask you to draw the grade, if they ask you to find gradient, mathematically, obviously, it's y2 minus y1 over x2 minus x1, right? But in this here, you actually have to draw the triangle and show how do you get it. And for those who until now, they still don't know, guys, when you are finding points from the graph, it must hit the axis exactly, guys. So if it hits axis here, like this here, okay, I can use this. If it hits the axis here, okay, I can use this. You don't try to be funny, you use something like this, or something like this, or something like this, or something. Actually, this one is acceptable also, right? Or something like this, or something like this, or something like this. This one is, I don't think it's acceptable, right? Make sure it hits the grid exactly, guys. Only use the points, and when you draw a triangle, you don't just suka, you just draw something like this and then draw something like this. The triangle should also be at least 50% of the graph. It should be at least 50% of the graph, not a small little triangle here that you found for fun, guys. Very important. Right, and yeah, this one here, nothing much. I just want to highlight that usually these two, the scales are not different. The scales, what? They are not the same. What did I say? The scales are not the same, right? So you don't assume that, oh, here is like 0.24, then here, oh, here is like 0.22. But in this case, it is but just be careful of the scales. Read it properly. It's usually going to be different. Okay, then everything else is literally just follow and read and plug in the numbers, which you definitely should not lose your marks, guys. If you for some godforsaken reason you cannot follow the damn instructions here, right, and you cannot plot in the damn numbers properly, you deserve to lose your marks also. Then this one here is literally just follow what they want, right? Follow what they want and draw the diagram. Should be easy by now. Everyone should know what to do already by now. And then these drawings here. Now I tell you, as soon as I see these drawings, right, automatically in my head, without looking at the question, usually I already know what the question wants already. They'll ask like, oh, what are the better ways to improve the accuracy of this experiment? What are the ways to measure the length of the image? What is the ways to set up the apparatus properly so that you don't lose, you make sure it's a fair experiment. Let me tell you, these are damn standard questions with damn standard answers. First and foremost, you must make sure that each and every one of them is perpendicular against the bench. This is the first point that everyone must know. And then you should move this screen left and right until you get a sharp image. This is the second one. Conduct this experiment in a dark room. Anything that has to do with light, you must conduct it in a dark room. And number 4, usually they'll ask you, like, there's going to be an image generated here, right? They'll usually say that, oh, if you measure with a ruler in front here, it's very hard to measure the exact size of the image. So what do we do again? What do we do again, guys? If we want to measure the size of this image generated on the screen. Maybe the Asian students can answer me since you guys are going for the exam. What do we do? Sandra, what do we do to measure the size of this image? If I place this ruler here, obviously the light will be blocked by this ruler, right? Then it's going to obstruct the image, right? What can I do? On top and the bottom, okay. That's actually the same as measuring how the length is. So no, that's not acceptable. Yugen, what's the answer? What should I do to measure the size of the image? Yeah. No, you fools. Use a semi-transparent screen, right? Then you can measure at the back of this screen here, that it would not obstruct the light rays. Remember, it is a standard question, guys. This is a standard question. Make sure you know this. This screen should be semi-transparent, right? So that when the light hits here, this screen here, you can use the ruler at the back and measure without obstructing the rays. Remember, guys, this will very well come up in your exam. Translucent screen. Does translucent mean semi-transparent? Is it? I think so. I think if the answer is yes, then yes, you can use that. But if not, just use semi-transparent screen. And then every time you see the tables, make sure you see that the units are all set in. Then follow the sequence, shut up, don't touch my shit. Okay, then yeah, I think all this, I'll be careful with this one also, guys. Now you see, if the question itself, right, already give you 5 this, you don't have to purposely mention it. Remember, I told you guys before, when you're doing these experimental questions, you should be using 5 sets of value. Never heard before. Good luck later, right? Although shut up, idiot. Okay, 5. If they already give you, then you don't have to purposely mention it. But you must mention that you repeat the experiment at least 3 times, guys. You must mention this, right? Oh, and this one they don't even talk about. What? Shit, this is not even it. State key variables. Usually they just want you to for the control variable. I know a lot of you guys in school, the school teachers, they teach you the what constant variable, manipulated variable, and independent variable, right? All those no need to write. Now it's like write for fun only on. You just the key variables here to control is the thing that you must make sure is the same, so that every time you conduct the experiment, it will give you fair results. Okay, for example, maybe you could say the same amount of heat supplied to the insulating disc or metal disc, or you could say like the time taken that you heat it up is the same, something along these lines, right? And in fact, if you look at the mark scheme, they don't care about the independent, dependent, or whatever. They usually care about the key variable, the constant variable only, the thickness of the disc, so that each experiment is the same, temperature of the heated cylinder, initial starting temperature, power supply, and the time for heating. And you see, it's even 2 marks here. Wow, this year they give 2 marks. Usually, guys, the previous years, you have to write 2 to get 1 mark. This one here, they give you 2 marks for the 2 key variables. Very important. A lot of you guys actually have a very bad habit to only write 1 key variable. It should be key variables here. So it should be 2. Okay, very important. Yeah, and then this conclusion also, I see some of you guys always give me very funny questions and funny answers also. The conclusion is always by comparing the 2 things that you measured, right? For example, in this scenario here, maybe, what's the scenario? Actually, what's this experiment? Do we have to specify state like depend? I just said no. You just need to state the key variables that you should be controlling to make sure it's a fair experiment. So the conclusion is usually comparing the x-axis and the y-axis, or the 2 things in the table. I didn't really read this question, but it should be something like this. By comparing the temperature versus the time taken, whichever one is the longest is the best insulator. Something along these lines. It's always by comparing this with this to reach the conclusion. You don't know the conclusion, guys. I've said this multiple times in class before. You're writing a step-by-step guide so that any idiot or any asshole that walks into the lab can conduct this experiment. What? Okay, so yeah, this is one of the things that I wanted to highlight. The second thing was the light ray diagrams, which I've also mentioned before in class. Let me see if I can find one. Okay, this one also I want to highlight a little bit here. In this question, right, I don't know if this one has it or not, but somewhere along the line they will say that, oh, how do I measure the extension of this spring to as accurate as possible? What you usually do is you say you could use a set square, right? You should use a set square, make sure it's resting on top of whatever this thing is hanging on, right? Use a set square and place it as close to the spring as possible, and then measure the extended length versus the original length here. Right, sorry, the extended length you need to say is this versus this here. Right. Then you minus it off, you'll get the extension. In anything that needs to measure the length usually you should think about how you're supposed to use a set square to make it as accurate as possible because it must be perpendicular lah, right? So that's the whole idea of the set square, right?
What is that?
The square is the triangle square that you see in the damn compass set.
Oh,
You know the triangle square, the triangle ruler, you know, then that has measurement here and measurement here.
ruler.
Huh?
Ruler.
No, usually the answer in the mark scheme they require you to use the set square. I know you asked the IGCSEs that's why I see them. That's why I'm telling you, bro. I just told you it's because to prevent to make sure that it's as perpendicular as possible. You know, they want to make sure it's perpendicular as possible. So I will assume that if you use a ruler, you can, for some godforsaken reason, maybe your ruler is a bit slanted like this, right? Then you measure, then it'll be wrong, lor. But if you set scale, you rest it here already, then it will for sure be perpendicular, right? That's the idea, lah. That's the idea that I justify in my head, lah. Exactly why? I don't know. Maybe they like the set square more. Maybe for somehow, you know, it's a conspiracy to push set squares because God knows no one actually uses those things, right? But every student will have it. But whatever it is, just please go read the mark schemes a little bit more for Saturday, Sunday, and Monday, right? Before you go for the test on Tuesday. For those who have still not practiced any paper 6 questions, please go do as much as you can. You should be doing at least 6 sets before your Tuesday exam. Very important. Very, very important. You see, like this one here, straight away, the first thing I notice is that the table, the units are empty. So you have to write time in seconds and degrees Celsius and degrees Celsius here. Oh, by the way, did they ask about Kelvin this year for the paper 4? Oh, they asked about absolute temperature. Luckily, I highlighted that day on the Saturday class. Did I highlight it on Saturday? Yeah. Oh, did I highlight it? Wait a minute. Did I highlight? Did I? What? Wait, oh, it was you who asked me the 273 thing, right?
Oh, you asked like the conversion.
Oh,
That's for the absolute temperature.
oh, shit. But you guys know what it was, right? Okay, this is the thing I wanted to highlight, which always comes up in the exam. Guys, this one here is literally 3 marks, guys, but you need to know how to get these 3 marks. Most of the time, they will not include these 2 pins here. They will not include these 2 pins here, right? And because they don't include these 2 pins, what did I say was the golden rule again? How far should they be apart? If let's say they ask you to draw pin 3 and pin 4, how far should they be apart? I'm going to take a wild guess. Answer me now. How far should they be apart? 5? Yes, very good. It should be 5 cm apart. If let's say they don't give you this and they ask you to draw, you should draw your pin 3 and pin 4 at least 5 cm apart. It is a must, guys. It is a must. Then after that, it's just literally follow instruction all the way. Follow instruction all the way. And then if you see these kind of questions, state whether it is acceptable or not and explain your answer. What's the statement always going to be? If let's say the values are very close, like they say that 1 is 1 and 1 is 1.1 cm, then your statement will be yes, it is acceptable, right? Then the explanation will be the difference between them is very small. It is within the experimental limit of accuracy. This type of question always comes out in your paper 6. Please use your brains a little bit, right? And look at this question and see the difference. If let's say one is 1 cm and another one is like 2.5 cm, then below of course cannot, right? Because this is like literally 2.5 times apart already. Even though the difference is only 1.5 cm, right? But the difference between them is almost times 2.5 already, right? So if you times 2.5, then your explanation will be no, it is not the same, then your explanation will be like, because the difference is too large, it has exceeded the limit of experimental accuracy, guys. It has exceeded the limit of experimental accuracy. Very, very standard question with a very, very standard answer. Please make sure you go do your classes. Then after that, if they ask about all the ray tracing one, they'll say state 2 precautions to take in this type of experiment to ensure the accuracy of these results. It's always the same answer once again, because it's conducted with light, right? So you got to make sure that it is conducted in a dark room, and you must use very thin pencils to trace the rays, guys. Super standard answer with a super standard question with a super standard answer, guys. Please make sure you know this. Yeah, I think that's about all the things that you should know. And I've sent you this file, guys. This file that I sent you that I was supposed to send you on Monday, right? Please read through this. It's very, very important. Actually, there's not much to highlight for paper 6. I think most of you guys should be able to do well for paper 6 so far, right? A good way to gauge whether you'll be doing well or not is when you go, how much do you get for a trial test for paper 6 out of 40? Don't know, too shit already can remember, or too good already can remember. 20, 30, 40, sorry, 40 is it near the 30 range or not? Okay, guys, for those who don't know, right, go home today, right, do one paper 6 on your own without looking at the mark scheme. Mark as strict as possible with the mark scheme once you're done, and see how much you get. If you score somewhere around 30, you are safe. Like anything below 30 means 29, right? You are not safe. Then you better do more of the papers. And if you need to do more of the papers, then obviously what you have to do is you have to, keep studying the mark scheme on what they want. Because paper 6 is seriously 3 marks paper, guys. There should be no reason why you should be scoring less than 30. If you score less than 30, then something is wrong, your understanding is not correct, then please do more past year papers and study the mark scheme, guys. You can't study the book from this. Okay, so anyways, this is just a small little compilation, which I see are very standard questions with very standard answers. I'm not going to go through each and every one of it, but I'll go through some of the things that I think are relatively more important. Number one, definitely this experimental accuracy. It is either within or exceeded the limit of experimental accuracy. I'll repeat that. And then what are the good procedures to do when you're doing all these experimental questions is definitely repeat the readings, avoid parallax error, and read the scales carefully. This one is like a God-known one, right? And then measuring volume, obviously you should avoid the parallax errors and read from the bottom of the meniscus. You should know by now also. Parallax error is like when you see this water, right? You don't read it like this one. You read it like this. Oh, a lot of water, This is what we call parallax error. Or you read it like this. Hey, why so little water? But it's the same. Okay, read at the bottom of the meniscus. You know what's the bottom of the meniscus? You know what's the meniscus, right? The water that sticks onto the wall. I mean, won't be so far, right? Maybe it'll be like something like this, right? You're supposed to read this, right? Right. Yeah, this one is not important. This one is important. This is the one that will very likely come out in your exam. This and this, the light rays, guys, the light ray experiments. You will notice it's exactly what I mentioned just now. Make sure the height and length are all at the same. Object are perpendicular to the bench. Use translucent screen, which I assume is semi-transparent. Use sharp pencils. Make sure the optical pins are 5 cm apart. Do experiment in dark rooms. Move the screen slowly left and right to produce the sharp image, and obviously repeat the experiment. This is important. Please read through this. Then procedure for ray tracing, which is the pin one. Make sure the rays produced are thin. Make sure they are at least 5 cm apart or 50 mm apart. Make sure the pins are vertical. Means to say you cannot poke it like this. You don't poke the pin like this. You should poke the pin down exactly like this, right? Then obviously use sharp pencil, mark the center of the beam, extend the rays, and avoid parallax error. This one is the key one. I don't know why when, but this one is not very important. You should know this. Oh, in case they ask about measuring temperature, the thermometer should not be touching the base of the glass. It should be like in the middle here. So it should be suspended by a retort stand, guys. You know this, right? So yeah, just read through everything. Yeah, this one is all the things that you should know by now. Yeah, all these are just read through it, guys. I think one way or another, the improving the accuracy one, everything read through, guys. Improving accuracy, all this is important. Make sure you read through everything. You might just see one or two of these questions come up in the exam. Okay, guys. Yeah, not much to talk about for paper 6. Let's do one question together, since we got so much time right now, right? Let me pick one of the years to do, and everyone that you have any questions, please mail it to me. Have we done this before? Anyone? Good. Let's do this question here. Shit. Let me send it. My God. I should just send it here, and everyone can get it. I'm gonna send it to a Zoom chat, guys, everyone. And then for those who are here, hold on a minute. Let me print this page for you guys. How many of you guys are here today? Wow, someone's already printing. People is printing a whole lot of shit. Hey guys, for those who are online, please start attempting this question. It will be best if you can actually do it on a piece of paper and then send me your answers for marking and whatnot. Yeah, start again. Updating the whole thing over there. In my head, I always thought that I needed to cover more things for paper 6. But I guess on Monday, guys, to utilize Monday's class the best way you could, it'll be better if you have and you have done some paper 6 questions, and then bring it on Monday and ask me whatever questions that you have. Because I think I covered everything already for paper 6. What else do you need, bro? 好玩吗？有想念马来西亚了吗？我欠你几多钱？
搬房。
欠你几多钱？比较好一点，保护费15块。那去买东西，然后给我再回来。
我要是忘记了呢？
忘记了就当请你吃。You don't know how to start. You're ready to take the exam again in October, November, is it? Jesus. Guys, if you have any drawing questions that you're uncertain of, Monday will be your last chance to clarify that, guys. I actually don't know what else do I need to tell you guys for paper 6 really. But I think it should be fine. I think everyone should be okay. So just good luck and have fun, everyone. But don't worry, the October, November students, you still got plenty of time. Unless you also want to be an October, November student. Have you been doing anything for 6 questions? Oh, paper 4 啦，这physics. What does the question want from you? What do they want? They don't know that. Okay, what experiment are you conducting? Read the question carefully first. Okay. 哇，你不要会做你这个这个比更周到是很多方面的。So, how strong and loaded this is
what you're trying to do for this experiment. You think about it, what should you do? 现在我先做艺术高度单先咯，对吧？然后 what's the first thing I need to measure? Initial 我的功能 OK。length 啊 width initial length 是 measure 先，然后我 load 了看它 extend 多少嘛，right then 我知道的这个是它 extension 了，then after that maybe I'll add 2 more loads to make sure that it's the same spring constant 啦，right then after that 我就 replace 这整个 rubber band 我放一个厚一点的 because different width 是吗？我有薄的，我有厚的 rubber band 嘛，对吗？然后我 replace 了，我再 load 看它 extend 多少，再 extend 多少。You should expect that as your big explanation.
Write something now.
Oh, see, both of you guys are stuck here also. So tell me, girls, so what should we do for this experiment? What does this experiment want from us?
那去走来。
So what's the point of this experiment? What do they want us to start? Very good. This is the thing that we're supposed to conduct now. Right. So this is what we're going to do. And then 他就讲了哦，他有给我们 different widths 嘛，different widths 嘛。Right. So these things, please highlight it somewhere or just draw a circle around it so that you know what's going on, what we're going to do. Right. And this is the experiment. So that much. Right. So 大概就是这样子的话 what you want to do is you want to first place our line here. Then you're going to go to different weights. Okay, you go to 5 cm, sorry, 5 newtons, see how much you can extend. Go to 10 newtons, see how much you can extend. And you go to 50 newtons and see how much you can extend. Okay, you have to definitely measure the initial length. You have to measure the extended length, find the extension line, right? Then after that, you're going to replace this rubber band with a third weight one. It's a whole width. Right, whole width. I do the same thing, right? And this is how we're going to conduct the brief explanation, right? Right, something after this.
但是如果你用同样的这个 length of the length，
明白
yeah，
？OK，
你还需要它的形状吗？你直接找这个 length， 你直接找那个
I mean, logically, yeah, but if there's no fixed answer, if let's say you say that make sure they are all the original length, the same original length, right, then just find the extended, find the extension by minusing off the extended value. It's okay, depending on how you write down. Different outline, different width, because one different width, right? And then place different load onto the port and see how much each different outline. So that you can use the width to measure but you can add one more thing on it. You say first, you say something like first, you have 5 different order lengths, but same length, the different widths. Yeah, because the widths that will be fine. So I'll say is that I'll have 5 different order lengths, same initial length, different widths, right? And the first one I'll take and I'll take as the parameter shown above, right? And I'll start loading them with 5 Newton, 10 Newton, and 15 Newton. Certain amount of I mean, because we have different loads, because I want to see if it exceed the extension limit, the what's called limit of proximity. But it's actually not so important. So I'm sure the marketing will get the I would have put something like that. Right. So after that, right, I've done the first one already. And I obviously must say something along the line. I can measure the initial length, I'll measure the extended length. Then I'll find extension by taking the second minus the first one.
Okay, then after that, I'm going to repeat the experiment with different widths, and then that will be your start rate. Okay, so see how you want to calculate. This is not wrong. Okay, this is actually quite. But it's best if you say something like somehow you must mention you have 5 different program widths. Oh, 5. Bro, I told you already, it's 5, bro. 5 is the golden number. Good, how? Where's your key variables that you should control? And I told you just now, right? It should be 2 key variables, right? Where is it? Okay. I recommend this to all the students also. Don't write your key variables in the sentence. You should like at least use a different paragraph to say that key variables that I controlled in this experiment is the initial length of the rubber band and the loads that I used to measure. Oh, this one for some reason. My recommendation is this, guys, when you're writing the key variables, don't include it in the explain briefly in your experiment, guys. I don't like to do that because imagine this, the guy that's marking your paper, right? He's not only marking your paper, hello, he's not your personal exclusive marker, he's going to mark 1,000 papers, and at some point he must get lazy, right? And at some point he must be just looking for the keywords in your paper, right? If you differentiate it by paragraphs, then he doesn't have to search for the answer. He can see, oh, this is that, this is that, this is that, this is that already, right? Mangi, why do you repeat the experiment with the same rubber band width repeat? Oh, okay. Mangi, for your step 5, right, repeat the experiment at least 2 more times with the same rubber band width to get an average result. And now values, repeat experiment with rubber band of different width. And then Mangi, your rubber band width, I just said, right, it should be 5 different cms, right? And then for this one, you can bullshit the value. For your rubber band width, maybe you say something like 1 cm, sorry, 2 cm, 4 cm, 6 cm, 8 cm, and 10 cm. Wow, 10 cm rubber band width. Maybe not so logical. Maybe you write 1 cm, 2 cm, 3 cm, 4 cm, and 5 cm for the rubber band width. And then your control, right?
I just said in classes now, don't need to write the independent and dependent variable. You can just write the key variables here, which in this case should be the same rubber band length and the same loads applied to all different experiments, ma. Load before breaking. You don't need to write load before breaking, because you're not expected to break the rubber band, so you just write load in newtons and can already. And then you should be measuring the initial length and the extended length, right, to get the extension. Why would you need the average load? You don't need the average load, for sure. Wow, a bit 亂水, your table, Mangi. The greater the bar bandwidth, the greater the rubber band can load. Wow, I think your answer is a bit off, Mangi, for your experiment, because I don't think you know the key objective here. The key objective was this one, is to investigate how strips of rubber band of different width stretch when loaded. You wait for an answer. I will see who has a relatively good answer, and I'll send a model one for the group. The insurance of the rubber band. It should not be types of rubber band, Leo. It should be width of the rubber band. So like I mentioned, it should be width 1, which is 1 cm, 2 cm, 3 cm, and 4 cm and 5 cm. Wow. Super simplified, your answer, Leo. No, the rubber bands are not supposed to break. You're just supposed to see how they load, how they stretch when loaded only. Mangi. So far, no one has given me a proper answer yet. Let's see. Don't need this first statement. Just okay, you see how if they have the diagram like this, right? How you can do is to simplify and not waste too much time. The apparatus as supposed to set up and out already. You don't have to see that with what W this is the way the apparatus as supposed to set up that you have save up all this time writing all this radio, because actually this is actually this radio. I mean, it's not wrong. If let's say you're tag on time, then how do you still write all this? Because this one no mark on the just say the stack up as above, the apparatus as above is set up. Then how do you like this is one thing already. Then after you can really go into the demand. You're going to say, well, please the first of all, you prepare 5 different organizers, different way, and then you stay on here at 1 cm, 2 cm, 3 cm, 4 cm, 5 cm, and put. And take we go 5 cm sorry like this. Then imagine the rubber band that's like 10 cm like this. It's like 15, it's like 15. Come on, this is too big already. This is too big, it's not realistic. But in the max scheme, they don't penalize you, but in case the guy in song is thinking about which would 5 cm as the thickness. I think You definitely follow marking scheme, but I wouldn't like it like that, lah, sure.
And we should have back on the road. Please, hold on, sure, and time to ball with once you repeat the experiment 3 times, you did not state repeat the experiment 3 times. No, but the key variables is one thing, but we need to actually repeat the experiment 3 times. For each week, we should repeat the experiment 3 times stated here. Right? Wow. Yeah. I think I'll write an answer. I don't see a nice one. Can you
Like, to be like, I didn't give you like different roles.
those ones, I should 9. Also, it's not simple one, yeah. Okay. I'm asking you super simplify one, but you should structure your answers based on it. Okay, everyone, I think you had enough time to attempt it, guys. And I must say, looking around at the answers, I'm not quite confident with your last part here, guys. Yes. And those who told me, right? I'll tell you now, buddy. Go back and do more past year papers and read the mark scheme and think about how the experiment is. Ideally, you would want to write this step-by-step guide for any idiot to follow. Like literally, that you gotta imagine this. That guy, right? It's like probably brain damage a little bit, right? Then whatever you write here, he just needs to follow the instruction one by one, and he can conduct the experiment. That is a very important thing, right? So, yeah, if you look at the mark scheme, right? Honestly, the mark scheme is super simplified, meaning to say, if as long as you hit the keywords here, right, you will still be awarded your marks. But my recommendation is still the same, right? Write it as if some idiot is following your sequence. So what you definitely have to do is you definitely have to measure the initial length of the bands first off. Right, this is number 1. Right, this 3 parts here will usually be the briefly explained, the briefly explained part. Right, then you're supposed to hang loads and measure the new length. Right, then repeat this repeat with different thickness. So in between, right, you'll notice that, hey, how come I keep saying need to repeat experiment 3 times, but in this part here they don't even mention it. Usually it will be at the 1 additional mark here, right? Use at least 5 different thickness, use the same load, the same range of load. There's a graph, show measurement extension, use the same type of rubber band. In fact, this one here, these two here, this first one here, use the same load and use the same type, is actually in the control variable area. Meaning to say, in this one, they are more flexible. They give you many ways to score your hidden mark, right? Like I've mentioned before, this one here, if there's only 4 bulletin points here, right? There's only 4 bulletin points here. It means to say, one of it will have more than 2 marks. Sorry, more than one of it will have more than 2 marks. In this case here, it will be like 3 here, 2 here, 1 here, and 1 here to get your full 7 marks mark. Right. So once again, you should structure your story something like this. It's always good to repeat the experiment 3 times to get an average. In this specific mark scheme here, they do not specify. But my general rule is, for your sake, not mine. I don't care if you write it or not, guys. For your sake, guys, it's for your sake. You would always like to repeat the experiment 3 times, because more often than not, in the mark scheme, they do include the repeat experiment 3 times as your hidden mark. Okay. Then control variable is obviously use the same length or even use the same type of material or use the same load, right? Then obviously the table, you must have the thickness,
the length and the extension, the units are important. If your table doesn't have units, you will automatically lose this mark. And the conclusion is always going to compare this versus that. Plot a graph of extension, and then whichever one has the greatest amount of load, whichever one extends the least has the greatest spring constant, or you just compare the extension versus the length here, right? The different thickness. However way you want to structure it is also acceptable, guys. Like I said, paper 6 is actually very lenient one, guys. Paper 6, they're actually very lenient. They don't really want to minus your marks. But if you don't write it properly, it's very hard for them to award you your marks as well. For those who like to have one big paragraph with all the points inside, my recommendation is don't do that. Right? It's best if like you write something like, for me, my recommendation is right, this first part here, I'll write, and then I'll purposely leave an empty spot to write the second part here. Then I'll start writing. Key variables that should be controlled in this experiment is blah, 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 blah. And that's one more point. Then draw a table, then I'll draw a table here also, make sure I have the units and heading and everything, right? Then briefly explain the conclusion again. I'll say by comparing blah, blah versus blah, blah, whichever one is blah, blah is the best blah, blah. This is it's going to be the skeleton of the answer, guys. You'll notice this very much in the mark scheme as well. Please go back home and study the mark scheme for those who have absolutely no idea. And for those who are writing your answers all over the place try to sequence your thoughts more nicely. If you separate it coulomb by coulomb, you don't have to think about the whole experiment, you just have to do one bulletin point at a time. Then it's good enough already. One bulletin point at a time, one bulletin point at a time. You don't have to have the whole structure figured out. But if you do it one at a time, it will be much easier. That's my recommendation for everyone here. Okay, guys. Since we have a little bit of time, I'll write one answer down for everyone, then you can see how I would have written the whole structure. Okay, we have 10 minutes left. For those who are not done with your paper, you can still continue doing it. For those who want to see my answer, you can copy something like this down. First, characters as and 5 then first what kind? Oh shit! First place one and everything on the time. You could expand 3 times and an average result and
Yeah, keep everything.
Yeah, this, I think this will be a little bit more sequence. Wow, bro, your picture is so blurred, bro. Good thing. Key variables. Don't write I, Kunling, don't write I in your paper 6. Just write key variables to control. Then dot dot with width of the rubber band. What? No, the type of the rubber band, the material of the rubber band, and maybe the mass of the load. Yeah, I think yours also is a bit funny. Just follow my answer a bit better. Oops. Okay. Wait. Oh, shit. And then after that, what do we need to do again? State the key variables to control. That, what do we need? A table. Draw a table. The table should look something like this one. Rubber band in cm is 1, 2, 3, 4, and 5. Then the extension. You got a L2 minus L1. And slash in cm. And then, yeah, I don't think you need this. You need like probably like initial length. But load. Yeah, no, you don't need the load because the load is going to. I only use one load only, man. Right. I mean, depending on how you want to structure the question, now, right? Initial length, which is in cm. Then after that, the new length, which is in L2, the cm also. then your extension, which is obviously in cm also. Right, please draw it nicely in your own table. Okay. Then the conclusion. Explain briefly how they reach. Oh, new length. I just didn't have enough space. By comparing the thickness of the rubber band versus the versus the extension and what's the three boxes on the table? Initial length, new length, and extension, all measured in cm. Something along these lines, guys. Seriously, it doesn't have to be word by word. You could construct it your own way. Try to think of the most simplified way you can. Initial length, new length, and extension. Okay, guys. Yeah. Please, everyone here, not just the major students, yeah. Everyone here, please go back and start doing some paper 6 questions. If you have any questions, you can clarify with me on Monday, guys. Yeah, and please don't neglect this last question because it's worth 7 marks, guys. Very, very, very important. Okay, guys, that'll be it for today. I'll see you all on Monday, guys. The last class will be on Monday. Say goodbye to all the major students.
Oh wait, I have a finished copying.
Oh, okay, sure.